What test do we have for convergence so far? Okay, geometric, right? Finding an R, right? Exactly. But it is limited. It's limited to the fact that the series must be, what kind of series to start with? It has to be geometric. It only works on geometric. There is no one-size-fit-all grandmaster test that will work on every single series. Okay? It is, if the series is geometric, we use this test. If the series is not, then we have other tests to use. So we will be accumulating tests as we finish up chapter 10. So here is your second test. It is called the nth term test. Nth would be the final. If you could find a final term in an infinite series, that's what it is. The final term test. Okay? Or the general term test, if you want to think of it that way. That's maybe a better word. Okay, the general term. Okay, now there is a limitation to this one, and it's kind of a biggie. It only proves divergence. It cannot prove convergence.
Wait,
yes?
If you prove that it's not divergent, can we still say
No, the opposite of being divergent is not necessarily being convergent. It is inconclusive. Okay? It is just an inconclusive. It may, the opposite of that it may or may not be, but it's not for sure one way or the other.
Is it straight line?
Okay? What is the general term for a straight line?
There is no slope. Linear?
What kind of slope? Are you talking about horizontal line or an oblique line? So they're different. Oblique is the line that's slanted and not horizontal.
Oh,
Okay, horizontal line is convergent. All right, here's the test. You find your general term, and if the limit, the infinite limit, so the limit as n approaches infinity, of that general term a sub n, if that does not come out to be 0, in other words, if the nth term, the general term, is non-zero as the limit approaches infinity, then the series of the nth term, okay, that means the progressive sum of all of those, is divergent. That should make sense to you. If the last term, and I know we can't get to a last term, if terms way out at infinity aren't 0, if they're a number, then if you're adding up all the terms to that, they're not going to converge to anything because you're continually adding to it, and so it's going to keep diverging. It is not convergent. However, the converse is not true. If the limit as n approaches infinity of the general term is equal to 0, we conclude nothing. It doesn't prove anything if it is equal to 0. It is not divergent, it is not convergent, it is an inconclusive result, and you need a second test, which we're going to also do today. Okay? So we're going to do one sample where it comes out to be divergent, and will be one sample where it comes out to be inconclusive, and then I'll teach you the test to do after that. All right, so at some point you'll want to make a little flashcard for this guy, but probably not right now. All right, here we go. Okay, these are not geometric series. If they were, we would do the geometric series test, but they're not. So here we go. The sum, and starting at 0, going to infinity, of the general term 3n over n plus 2.
So this is for arithmetic sequences?
Not necessarily any kind, any non-geometric. Doesn't have to be arithmetic. There could be
Not geometric.
non-geometric. Okay, so it's not a geometric series because nothing's being multiplied here, raising to the, you know it's going to be multiplied if it's raised to the nth power. That'll be geometric. This isn't. All right, so we're going to check it. We'll do our test. We take the limit as n approaches that upper bound of infinity of the general term. We plug infinity in. We get 3 times infinity over infinity plus 2, which is infinity over infinity, which is what? Indeterminate. So we apply L'Hopital. Pause. Now, we need L'Hopital. So what's the derivative of 3 to the n?
ln
3 to the n itself times ln 3 over the derivative of n plus 2 is 1. We can put infinity into that. We get the natural log of 3 times 3 to the infinity, which is infinity, which isn't 0. And as long as it isn't 0, then our conclusion can be that this is divergent. That's the only conclusion we can make. As long as it's not equal to 0, then that series will diverge. Because the terms, the nth terms, the general terms, are just getting bigger and bigger and bigger and bigger. So the series, as you sum, is just going to get bigger and bigger and bigger. Therefore, it diverges.
Why on the grades was n not a variable, but now it is? Because we were like, oh, n is just a number. So then
Because we were working with power series that had x's in them.
it doesn't have x in it and it's a variable.
It is the only thing that is changing. They are. Okay, so the series this time, again starting at 0 to infinity, the general term this time is 2n over n squared plus 3. Okay, I got it right. All right, so we'll test that out because it is not geometric. Okay, our test is going to be the limit as n approaches infinity, 2n over n squared plus 3. Okay, 2 times infinity, infinity squared plus 3, infinity over infinity. Now you can tackle this a couple ways. You can do L'Hopital because it's indeterminate, or the other technique when you're dealing with polynomials is you can divide everything through by the highest power of n.
Oh,
Yes?
I was thinking, can you just divide it by n? And then
That's what I'm saying. You can divide through.
Oh.
It's like there's an echo in here or something. Okay. All right, so we're going to divide. Okay, I'm going to divide through not just by n though, but by n squared. I mean, I could divide by n, but then I'm going to have to divide by n again. So I'm just going to divide by n squared. That'll give me 2 over n over the quantity 1 plus 3 over n squared, which will give me 0 over 1 plus 0. So I get 0. Ergo, this is inconclusive. This test is inconclusive. Yeah, I can't tell you if this converges or diverges yet. I haven't proved it. I might have a hunch, I might have a gut, I might have a funny feeling that it's going to do one or the other, but I haven't proved it.
So, inconclusive is not the same thing as indeterminate. Right?
Correct. Indeterminate is a different. Inconclusive means it's not proven one way or the other. Indeterminate are specific things, infinity over infinity. 0 over 0, infinity to the 0, infinity minus infinity. Those are indeterminate terms. All right, so that leads us to our second test, which is called the ratio test. All right, this one works really well on exponential sequences and factorial sequences. Okay, works well on exponentials. And factorials. Okey-doke. All right, so the ratio test says to do the following. We want to compare the single term a sub n to the term that comes after it. What comes after a sub n in a sequence? A sub n plus 1. Okay, so we want to compare those two things in ratio to each other. And so you want to take the second one and set it up as a ratio to the first one. So a sub n plus 1 would be over a sub n as n goes to infinity. Yeah.
Is this still assuming that this is simply that it's a non-geometric?
Of course, yes. If it's geometric, please just go back and use the geometric test, 100%.
And it still proves divergence?
Okay, this will prove both. Actually, we have 3 results for this. The nth term test is either divergent or inconclusive. This one will do both divergence and convergence, but it also has an inconclusive result as well. All right, so we have 3 results. If kind of. Okay. All right, if the result is greater than 1, we have divergence. If the result is less than 1, we have convergence. So what's the only remaining? Yes. If the result equals 1, it is inconclusive. And we're going to need another test, which we'll cover Friday. Similar, yeah, between the result between the two. It's like if you divide one by the other. Mm-hmm. Yep, your mind is thinking. I like where your mind is going.
What about negative?
All right, so let's see. A negative is less than 1.
What about negative 1?
Oh wait, we're not proving that it is.
Yeah, we're not proving that it's not. The double, triple negative. Okay, here we go. N equals 0 to infinity, with 3 to the n over 5 to the n plus 1. No, this is the sequence.
Oh, okay.
Okay?
Okay.
So what are my 2 terms? Well, my a sub n term is simply 3 to the n over 5 to the n plus 1. But what's my a sub n term? 3 to the n plus 1 over 5 to the n plus 1 still plus 1. Oh, yeah.
I was like, I'm so confused.
Plus 1.
Okay, got it, thank you.
All right, so now we want the limit. 1 over the other. That could get messy when you have one fraction on top of one fraction. So what might look a little better?
Multiply by their simple.
Yeah, let's do that instead. I'm going to switch colors so we're doing our test. All right, here's our test. So we want to take the limit as n approaches infinity of the second term, so 3 to the n plus 1 over 5 to the n plus 1 plus 1. And I want to multiply, instead of dividing it, I'm going to multiply it by the reciprocal of the other. So 5 to the n plus 1 over 3 to the n.
So,
Okay. Ooh, okay, let's talk about how to reduce correctly. Okay, so what am I left with?
3 times.
Okay, 5 to the n plus 1 over 5 to the n plus 1 plus 1 don't reduce each other in any way. You can't reduce addition, you can't reduce those, but the other ones, the 3 to the n plus 1 and the 3 to the n, do reduce each other. And what am I left with? 3. Because we have one more 3's in the one more 3 in the numerator than we do in the denominator.
and we can't do it to the 5 because it has
The plus 1. All right, so we get 3 over 1. Okay, if I plug infinity into that, can you tell what's going to happen? It's, yeah, 5 to the infinity plus 1 times 3, and 5 to the infinity plus 1 plus 1, infinity over infinity.
Oh my
Okay.
God.
What did I do? That was strange what I wrote there. Okay, all right, so we're going to take L'Hopital one more time, or one time. But that's,
Is it possible to divide it by 5 to the n?
sure, but it's easier to do L'Hopital. Okay, because what's the derivative of 5 to the n plus 1? 5 to the n times ln 5. What about the plus 1? It's gone, right? Okay, what about the derivative of 5 to the n plus 1? 5 to the n plus 1 times ln 5. And then I still have my 3. Okay, well, what happens to the 2 ln 5s? Reduce. Okay, and what happens to the 5 to the n on the top and the 5 to the n on the bottom? They reduce as well, and I get 3/5. So my result was, in what relationship to the number 1? Less than 1. Therefore,
It converges.
it converges. And so my original problem is proven to converge.
Why do you have to use the first test if we can just find convergence that reduces and inconclusive for the second?
All right, because the second one doesn't work so well on polynomials, square roots, logarithms, other ones. It really works best on exponentials and factorials.
Okay.
Okay? Yes, sir.
Do we have to do L'Hopital? I think it's actually easier to divide everything by 5 to
Go for it. You certainly can. Okay, my last one. All right. These series that 4 to the n over n plus 2. Okay, this has an exponential, and it's not geometric, which lends itself well to the ratio test.
Wouldn't we just diverge because of our first example?
You could, yes. So you could choose. There's going to be parts of your homework that say you may choose which test you want to do. So this is very much like our first example, which was 3 to the n, which also we concluded it diverged. Okay, and we're just going to show that this test shows it diverges too. So you'll have there are multiple ways to skin a cat. Okay?
Okay.
Yeah.
It's terrible though.
All right, but I'm just going to do the ratio for practice. Okay, so we want to take the limit as n approaches infinity. You want to do the second term divided by the first term. So I will have 4 to the n plus 1 over n plus 1 plus 2, which is n plus 3, times n plus 2
So like any n, you add 1,
to all the n's.
not just the.
Not just the powers, right? Any n. Okay, I can reduce the 4's. So I will have, or what I can't reduce, I have n plus 2 on the top, I have n plus 3 on the bottom, and then when I reduce my 4's, I get 4 over 1. Okay, at the moment, that is still indeterminate. So you can either divide through by n, or you can do L'Hopital. If you do L'Hopital, you get 1 over 1 times 4. Either way, the answer is 4. Relative to the number 1, this is greater. And since it is greater than number 1, the original series diverges, or is divergent, because it was greater than 1, which I could have proven with the nth term test also. So the homework will say, determine the convergence or divergence of the following series. Identify the test you used. Okay, so you just state ratio test, or nth term general test, or geometric series test, and just identify it and move on.
So you're saying we don't have to show